Alright, so today we're talking about the altitude in Orthocenter. Now the altitude of a triangle is actually really interesting. It's talking kind of like about the height at any point in a triangle. So if I'm looking at a triangle, let's say this is my triangle. Okay, the height of my triangle isn't necessarily like the length of the side. That's not really the height. When we consider height, we talk about this perpendicular height here, directly from the angle down. Even if it's kind of like this weird triangle like this, we would extend the bottom line and then go from the angle straight down. Okay? That's when we talk about altitude. We're talking about this perpendicular height of a triangle. Okay? It can be inside or outside of the triangle because sometimes, like you can see on the triangle that I drew second, that outside one can be, you have to extend a line to create that perpendicular because there's no way you can do it inside the triangle to create the perpendicular. Okay, so we're just going to identify some segments here. So we've got AD, we've got CF, we've got EG. Those are my three segments that are inside the triangle. So if we look at AD, that's going from the point to the middle of the opposite side. We learned about this one yesterday. This is called the median. Okay? Then if we look at CF, we're going from the point perpendicular to the opposite side. So we're finding the height of C. This is altitude. Now let's look at the line EG. It's going from the middle of one side to some point on the other. And it doesn't say anything. Doesn't say if it's parallel. That one looks like it could possibly be a mid-segment, but because we don't know if this is cut in half, we cannot say. So not enough info. All right, so that was fun. All right. Let's now talk about the orthocenter. So the orthocenter is where all of those altitudes meet. So if you draw the height of all the triangles, all the angles of the triangle, they will either meet inside, on, or outside the triangle. And again, on right triangles, they meet on, and this time it's really cool because they meet on the right angle. So if you remember, the circumcenter met on the hypotenuse of the triangle. The orthocenter meets on the right angle of the right triangle. Okay, in acute triangles, the altitudes or the heights all meet in the center somewhere. And obtuse, they all meet outside, and you'll notice that they meet directly in a line with that obtuse angle. Okay, which makes sense because you're finding the height of that angle, so the line would have to go directly through the angle. Okay? Alright, so there's our three types that we could end up having. So this one, just like circumcenter, we can actually find fairly easily because all we're using is perpendicular lines. We can easily find this using a grid. So I'm going to graph this. So my first point D is over 1 up 2. So this is D. E is over 1 up 6. 2, 3, 4, 5, 6. And then F is over 4 up 2. This one's very kindly a right triangle, and I will be showing you why exactly right triangles are my favorite with these. Then we'll do one that is not a right triangle. It's a little harder. Alright, so first things first. We have to find the points. So I'm just going to mark them with red. There's one point. There's my other point. And there's my third point. Oh, I forgot to label my last one. F. D, E, F. Okay, so now I want to draw a line through this point, through point F, perpendicular to line DE. So I'm just going to put DE on a yellow line so I can remember that that line actually extends past where it is. And then if I want it to be perpendicular, DE is a vertical line. Perpendicular to DE will be a horizontal line. So then this would be my line that's perpendicular and goes through F. Oh, that worked out really nicely. All right, let's take a look at what if we do, we're going to extend FD this time. So I'm just going to kind of extend it. Now we're going to find where on ED. So DF is a horizontal line. If I want to be perpendicular to DF through point E, I need a vertical line. So then that is where that is. Now if you notice, they all meet at the right angle, which I kind of mentioned earlier. So that means that my point of concurrency, or the orthocenter for the altitudes, is the point 1, 2. So now I want you guys to try this on your own. So if you notice, you'll plot this. This one turns out kind of nice. Like you'll plot the point 0, 0, and the point 4, 0, and then the point 4, 2. This one should turn out super nice and fairly easy to do. Go ahead and try that one. And then let's see how this one turns out. So we do 0, negative 2. And this one's going to be a tad bit harder. Because all of a sudden you have an obtuse triangle. Okay? So, if you need a refresher on perpendicular slopes, if my slope was 2 over 1, perpendicular would be negative 1 over 2. If my slope was negative 3 over 4, my perpendicular would be 4 over 3. You flip the sign and the number. Okay, you learned that last year. You should be okay. We will reconvene back together when we're going over all the centers. So, you've got this one, I promise. You can do it.